year is approximately equivalent to running a 200-watt light bulb for the year. Virtually insignificant when considering the amount of energy it saves. The three operational phases. Phase 1, or fill phase. Oil-contaminated refrigerant flows by gravity from the chiller evaporator into the OAM Purger distillation vessel. Phase 2, or distillation phase. During the distillation phase, the distillation heater is energized, heating the oil-contaminated refrigerant, causing the liquid refrigerant to vaporize or boil off, pressurizing the purge vessel. When vessel pressure exceeds the pressure setting of the distillation pressure regulator, the regulator begins cracking open, allowing clean refrigerant to flow from the OAM Purger vessel to the lower pressure chiller evaporator or cooler. In the process, any entrained oil in the liquid refrigerant is distilled out and accumulated in the purge vessel. When the temperature of the accumulated distilled oil reaches 145 degrees Fahrenheit, the distillation phase terminates and the oil return phase is initiated. Phase 3, or oil return phase. During the oil return phase, distilled oil accumulated during the distillation phase is automatically transferred, pushed by vapor pressure maintained within the distillation vessel by the distillation pressure regulator, from the purge vessel to the chiller's compressor lubricating circuit, oil reservoir, or oil sump. Why do all centrifugal chillers need an OAM purger? Typically, there are three centrifugal chiller operating scenarios. Operating scenario type 1 are chillers that operate seemingly normal at full or near full load capacity most of the time, such as process chillers or air conditioning chillers in year-round warmer climates. Yet occasionally oil must be added to the oil sump. The question is why? Where has all the oil gone? The answer is it has migrated into the refrigerant charge in the evaporator. Theoretically, a chiller operating at full capacity should have the least problem with oil migration because this is when the oil return system, or eductor pump, is operating at maximum efficiency. However, this is not the true case.
You could even use a OAM purger on a type 1 chiller that runs at full capacity all year because oil migration continuously occurs, builds up in the evaporator. We've seen that these chillers typically float between 3 and 6% anyway, and the OAM will get you down to 0.5% oil entering in the refrigerant, thus saving a significant amount in energy saved.
Operating scenario type 2. This is the most common category and is typical of chillers where they are subject to frequent loading and unloading conditions. For these chillers, oil migration to the refrigerant charge can be significant. During periods of low load operation, the pressure differential between the low and high side decreases, lowering the effectiveness of the oil return system, or eductor pump, allowing excess oil to accumulate in the refrigerant charge.
On a type 2 scenario chiller, the OAM is still applicable since you have regular oil migration while you're running at full capacity and an increased oil migration during low load situations. Therefore, the OAM would be able to keep you at 0.5% oil instead of getting somewhere between 3 and 6, maybe 6 and 12% oil during that time period, thus still saving the customer or chiller owner a significant amount in energy savings.
Operating scenario type 3 is the worst scenario of all. These are chillers that operate most of the time unloaded below 30 to 40% capacity. Since the efficiency of the chiller's oil return system, or eductor pump, is directly proportional to chiller operating pressure differential, this is the worst case scenario for proper oil return. Prolonged low load operation quickly leads to severe oil migration into the refrigerant charge, often exceeding 20% and with devastating effect.
An OAM purger would obviously benefit someone in a type 3 chiller scenario. If the chiller is suffering potential shutdown, the OAM can be installed, return that oil as fast as it migrates over to the evaporator, and the chiller will be running fine, regaining capacity, and saving a significant amount in energy costs.
Many centrifugal chillers do not have an oil return system at all. Chillers without an oil return system invariably fall into the Scenario 3 category, regardless of load condition. Therefore, if you own or operate such a chiller, you simply cannot afford to continue operating without an OAM purger.
We know that over time, a chiller deteriorates. It wears, which means that the oil leaks out more. We also find that the possibility of clogging of passageways, if you will, which can affect the oil charge, those increase. So overall, the older a chiller it is, the higher the concentration of oil in the evaporator and the higher the opportunity to improve the performance of your chiller. Well, when you look at a chiller, a 10-year-old chiller, for example, that's not as efficient as a brand new chiller could be. The option of replacing that with a new chiller is obviously very expensive to purchase it, to install it, take the other one out. In many cases, though, there's other options where if you just go in there and treat that oil problem, if you will, you can get a good portion of that efficiency improvement without having to go through the major expense of totally replacing the chiller. The extra oil is causing excess energy to be used, and anytime we use excess energy, that causes more global warming gases to be put into the atmosphere, and clearly today's primary threat from an environmental standpoint is climate change.
The bottom line is this: there is no chiller that cannot benefit from an OAM Purger. You will save thousands of dollars, not just the first year, but every year you operate the chiller with an OAM Purger, forever. Not only will the OAM Purger save you thousands of dollars in energy cost, it also restores lost capacity. In addition, the OAM Purger helps reduce maintenance and prolong chiller life and refrigerant and oil life by removing harmful moisture and acids from the system. When you consider the OAM Purger's payback, along with other opportunities such as utility rebates, LEED, and Green Buildings Points opportunities, installing an OAM Purger on every chiller in your facility is no longer an option. Now that you know the facts, it's a necessity for corporate fiscal and social responsibility.
Oil migration is occurring, and that oil migration is increasing your energy cost on a daily basis. By installing an OAM Purger, we're getting that oil out of the evaporator as fast as it migrates over, returning it to the sump where it belongs, thus saving you thousands of dollars a year in energy costs per chiller.
Once oil gets into the chiller's refrigerant, it's very difficult to get it back out. In the past, about the only way an oil-logged chiller could be fixed was to either remove and distill the refrigerant or replace the charge with virgin refrigerant. In either case, it was a very expensive process and it required a considerable amount of downtime. As you are aware, most centrifugal chiller applications simply cannot afford to have a chiller down. Also utilizing the past methods of cleaning or replacing the refrigerant charge, the fix was only temporary. The minute the chiller was placed back into operation, oil contamination began all over again. Advantages to the chiller owner? The OAM Purger quickly cleans the chiller's refrigerant charge to only a trace level of oil. It quickly restores a chiller to peak operating efficiency. It substantially reduces energy consumption, saving the owner thousands of dollars in operating cost. The OAM Purger pays for itself. So, in effect, retrofitting an OAM Purger does not really cost the owner anything. In fact, retrofitting with an OAM Purger is a financial investment that keeps on paying dividends, in most cases, thousands of dollars per year. Finally, it reduces maintenance and helps prevent premature failure.
While the OAM Purger was originally designed to deal with the capacity issue associated with oil migration, we've learned, as we've installed these units, the additional benefit of the great opportunity for significant energy savings associated with the product, which has opened the door for potential utility rebates, LEED points, green building points.
The conclusion? Every chiller truly needs an OAM Purger.